Hello, good afternoon, everyone. So, welcome to the live tutorial session of Deep Learning IIT Ropar course. And today, in the week 10th, we will discuss about some of the important question that is based on the week 10 tutorial, means week 10 lectures that is uploaded on NPTEL portal of this course. So, I'm Abhishek Thakur, Primary Research Fellow at IIT Hyderabad. So today, like I came to my hometown, so there may be some internet issue. Just forgive me if it happens. Anyway, I've tried my best that there will be no issue. So we'll start the lecture. Uh, Today, most of the questions are based on convolution, stride length, and filters, those kind of things. So you have already seen the lecture, then it is easy to understand this tutorial session today. If not, then you can see this, your basics will be clear, and then after that you can watch the tutorial. Then you can watch the main lecture. Okay. So if students have not joined now, so you can also watch this lecture tutorial session on YouTube. This video will be uploaded and the link will be given on the course uh, NPTEL portal for this course. The link will be there. So we'll first start with convolution. So here, like you can see, this W is given. Just we all know what is the formula of convolution, but we'll see like how to do it, like in 1D, 2D, and 3D. So in 1D, this is simply the formula ST is equal to XT minus A W minus A. So this will become ST is equal to, let's suppose A is from 0 to 6, like here you can see the weight vector is W naught to W6. So you can write xt as here x t minus 6 W minus 6 plus x t minus 5 W minus 5 x t minus 4 W minus 4 plus x t minus 3 W minus 3 plus x t minus 2 W minus 2 plus x t minus 1 W minus 1 plus xtw naught. So this is the way, and like how to calculate mathematically. Like here you can see this is our w, this is our x. So we will take w in such a way that it is just taking the first six element of x. Okay. Now we'll multiply each element to each element and sum it. Okay. So this is our st, means s1. So here this is s naught. So here t will be 0. So that will be x minus 6, w minus 6, x minus 5, w minus. So what is the purpose of doing like this? Like see, whenever we measure something, then there is some chance of getting error due to the sensor, like sensor is having some noise and all. So what we do in this, we can just taking the previous input and just add it and taking the average value of all these previous inputs, and weight is assigned in such a way that weight to the current input is higher than the previous input, because it depends on the current input only, like where is our vehicle or where is our sensor, and what output does sensor gives, that is totally based on the current input, but we are taking previous readings also, so that the error will be reduced. Okay, and after that, once it is done, again we will shift this w so that w will come up to like this. Okay, now this w is shifted. Again, we will shift w like this. So in this way, we will do. So this is the one way to find the convolution for 1D. In future example, we will also see how to find the convolution in 2D as well. Okay. So coming to the first question now, considering the example where we track the position of an aeroplane using a laser sensor. So one LiDAR sensor is used to track the position of airplane. Assume that sensor is noisy. We compute the weighted sum over a small window, that is W equal to 4. So weighted sum is calculated to obtain lazy noise estimate. Compute ST for the given values in the figure. So for this value, we have to find the ST. So what will be ST here? See, this is our W naught and W naught into XT. So this will multiply with this and this. So in this way, we will get 0.01 into 1.6 plus 0.1 into 2.0 plus 0.03 into 0.9 plus 0.02 into 1.1. So this will be, so we are just trying to find the convolution uh, for this. So like I have already explained why we do this. These are doing so that, like, let's suppose we are finding the current readings of the sensor, but sometimes sensor is noisy and does not give the correct output. So what we do, we just find the weighted mean of the previous reading also, so that the noise error can be minimized. So here just a question. So we have to just multiply these two because we have to find for this value, we have to find the ST. So this will be equal to 0.016, 0.2 plus 0.027 plus 0.022. Okay, so that will be 0.265 is the correct answer for this question. For here it will be 0.265. And also for next time interval, next time stamp, what we will do, we'll move W just one position next, slide it. So this value of W will come here. Now multiply and just write the value here. So in this way we calculate. This is the 1D convolution what we have taken in this example. So for answer for this question is 0.265. So we'll move on to the next question now. This is a very simple question. You can also answer these questions if you know in the chat box. Question is, suppose we have a 9 cross 9 input to a convolution operation with a 5 cross 5 filter. What are the dimension of the output? So generally we can find this using the formula. So width is equal to is W2, that is the width of the output, is equal to W1, that is the width of the input. F is the filter size and plus 1 we do. Yeah, correct option is 5 cross 5. So here W2 is equal to W1, that is 9 minus 5 plus 1, that is equal to 5, and H2 is equal to 9 minus 5 plus 1, that is also equal to 5. So W2 cross H2 will be the answer, that is 5 cross 5. So what happens in this? Let's suppose this is our 3 cross 3 input image, and we have divided this image into 3 cross 3, and we have a filter that is 2 cross 2. So first, what we do, we just multiply each element of these like 2 cross 2 into this 3 cross 3, and then sum it and give the output here. This is the output. So what will be the output for this? They're like 3 minus 2 plus 1. That is 2 cross 2. So from here one output will come. Now again we'll shift this box here. Then again one output will come here. Shift will box like shift this kernel down. Then we'll again get one output here. And shift this kernel down and rightward we'll get again one output here. So you can see that this formula is correct. Like W2 is equal to W1 minus F plus 1 and H2 is equal to H1 minus F plus 1. So now we'll move on to the next question. Before next question, we will see padding concept. There is a concept of padding, so that like here you can see the mm, output size is less than the input size. Like input was 3 cross 3, output became 2 cross 2. So now if we have to just take the output size equal to the input or according to the questions, then in that we can do padding so that we can increase the output size. Padding means like we can do zero padding, and different kinds of paddings are there. So in zero padding, what we do, we just keep zero in the outermost cell for this input image. Okay, so here you can see input is this, our input is this part. So we kept 1 0 in the adjacent row and column of this outer cells adjacent box. We kept 0, that is the zero padding. So after zero padding, what the formula becomes, this the in the previous formula only we just add 2p, so output will get added by 2p. So this is used to increase the size of the output. So we'll see this question. And also there is one stride length. In a stride length, what it means, like let's suppose there is a this is 3 cross 3. So first we'll convolve the first here 3 cross 3. Yeah. Kernel size will keep here on the input. Now what we'll do is the striding is, let's suppose 3. Then we will just jump 3 box. So one box will not start from here, will not start from here, will start from here. We'll jump 3 box, and from here we will start. So there will be a striding of 1, 2. So like that a striding will be there. So when a striding concepts come, then the output size reduces, and this is done to make the our network very faster. So we do a striding for this. So in this, just one formula, like this part is divided by our stride length. Okay, and in height also, this part is divided by stride length. So this is just a simple formulas only, and we will add plus 1. So now moving on to the question number 3. Last question, some of you answered B, that was the correct. So now we will move on to the question number 3. That for the convolution operation discussed in question 2, we find that the size of the output feature map is less than that of the input. What if we wish to have the output size same as that of input? Yeah, that we have already discussed. Padding is done so that size of the output feature map is made equal to that of the input feature map. Okay, so option B is correct, is right. Now we'll move on to the fourth question. For the convolution operation discussed, what is the required value of P? So whatever question we have discussed, what will be the required value of P so that the input and output size is equal? So we have 9 cross 9 input and 5 cross 5 filter. So input is 9 cross 9, filter is 5 cross 5. So what is the output here? That is 5 cross 5. Now we have to make input 9 cross 9. So what value of P we will keep? We know that the size increases by 2P. So we have to make it 9. So we have to add, here we have to make it 9 here, because we know the formula. Whenever we do padding, the size of the output feature map increased by twice the padding unit, that is 2P. So how much we will do padding here? That is P will be 2. Then only our output will be 5 plus 2P, that is equal to 9. So P will be 4 by 2, that is equal to 2. And here also you can see 5 plus 2P is equal to 9. P is equal to 4 by 2, that is equal to. So for the question number 4, correct option is C, that is 2. Okay, any doubt in this question? If no doubt, then I will move on to the next question. Convolve a 5 cross 5 filter over an input image of dimension 32 cross 32 cross 3 with a stride of 1. Pick out the output dimension for the same. So here it is taken as that the width of the filter and input image is same. So this is equal to, sorry, depth. This is the depth. So depth is equal to 3. That is also is equal to the depth. That is also equal to depth of filter. So now we will get a 2D in this question. This is assumed. It is missed, but can write here. So now what will be the output? Output will be 2 cross 2. So here again that will be the width will be 32 minus 5 plus 1, that is 28 cross, and height will be also is equal to 32 minus 5 plus 1, that is equal to 28. So this will be 28 cross 28. So option A is correct. Any doubt in this question? Yeah, option A is correct. We will move on to the next question. These are very simple questions. Now coming to the concept of blurring. So what we do, we take our input filter in such a way that image can be blurred or we can detect the edges in the image. So these we can do using the changing the value of each cell in the kernel. Like when we do convolution, if we keep values accordingly, then such kind of things will happen, like blurring or horizontal edge detection, vertical edge detection, these things. So in blurring, what we simple blur an image. Image looks more sharp or more detailed if we are able to perceive all the objects and the shape correctly in it. So what we do, the blur filter is given as like this, something 1 1 1 1 1 1. This is 3 cross 3. So in this what happened? Like in an image, let's suppose this is our image. Here this filter is kept. So this pixel will take the average of all the value nearby. So it will just become the blur. So image will become blur. Okay. The shape of an object is due to its edges. So in blurring, we simple reduce the edge content and make the transition from one color to the other. What we do, we just remove the edge content. We just take average in that area. Okay, just using such kind of filter. So mean filter is also known as box filter and average filter. A mean filter has the following properties that is used for blur operation. So it must be odd ordered. Odd ordered means it will be like 3 cross 3 or 5 cross 5 like that, and all the elements should be same and all the elements will be equal. Even we can do unequal blurring. In that case, the image will blurred according to the value in this kernel, in this filter. Like, let's suppose we give 5 here, then it is taking more color to this part. Let's suppose we keep this filter here. So now this pixel will have characteristics more similar to this part of the image. Okay, because here the input is 5, but if we keep 1, then it do perfect blur. Now there is also weighted average filter. In weighted average filter, we give more weight to the center value, due to which the contribution of center becomes more than the rest of the values. Like such kind of here suppose we give 5, so the weight of the center value is more, so it will take that color, what is the center of that this input, this filter. Okay. So due to weighted average filtering, we can actually control the blurring. So we have to, if we have to control the blurring part, then we just use this weighted average filter in which we give more value to the center of the filter. It should be also odd ordered, and the weight of the center element should be more than all of the other elements. So here the weight of the center element should be higher than other elements. Okay. So now coming to the question based on these concepts. Which of the filter causes blurring of an image? So this is a very simple question we have already discussed. That is option A. Because each element is 1, so it will make the average. So like if it is kept on the image, so that part will take the average of all the color nearby. So the image will become blur. Now coming to the edge detection, edges are calculated by using difference between corresponding pixel intensity of an image. Let's suppose this is our image. So if we like this will be continuous something. What we will do, we will just calculate the difference between these two and we'll take the center part as 0. In that way, there will be difference between it will be, the edge will be easily shown. So we will see what kind of filter is required for this. So all the masks that are used for edge detection are also known as derivative mask because we are calculating the difference between the edges. So this is also known as derivative mask. All the derivative masks should have following properties. It should have opposite sign so that it can subtract it and should be present in the mask. Sum of masks should be equal to 0. If it is opposite sign, then it will be sum will be equal to 0. More weight means more edge detection. If we give more edge, like we will see how to give the filter. Like for vertical edge, if we give more value here, like -5 or 5 here, then the difference in intensity will be higher and edge will be seen in a very good way. So in this, when we apply this mask on image, it gives the vertical edges. This filter is for vertical edges. Here you can see. It simply works like as first order derivative and calculate the difference of pixel intensity in a edge region. So what it happens, it calculates the difference between this to this vertical, like the pixel in this vertical line. So whatever pixel lies on this vertical line, it just create a difference, and the middle middle vertical line means the pixel lying on this line will become 0. So there will be intensity gap in between them because here it is -1, here it is 1. So it will gives the vertical edges in the output image. So as per the center column is 0, so it does not include the original value of an image, but rather it calculates the difference of right and left pixel values around that edge. You just calculate the difference between the right and left pixel values. So I will just erase this to make it neat. This increase the edge intensity and it become enhanced comparatively to the original image. Now coming to the horizontal edges. So this filter was for vertical, like 1 1 1 0 0 0 -1 -1 -1. Now for horizontal, what will be this? The filter will be in the horizontal way. Like the 0 row will come in middle and here it will be 1. Either you take -1 1 1, both are equal only because it is creating the difference between the top and below edges. Okay. So this is also the filter for horizontal edge detection, the right side. And this is also, here we kept -1 as top and 1 as bottom. We can keep anything. So this mask will detect the horizontal edges in an image. It also works on the principle of like calculating difference among the pixel intensity of particular edge. As the center row of mask is consist of 0, so does not include the original value of edges in image, but rather it calculates the difference of above and below pixel intensity of the particular edge, thus increasing the sudden change of intensity and making the edge more visible. Okay. So now we'll move on to our question part. Identify the purpose of the filter given in the following figure. So just answer me because we have just now discussed this concept. Answer for question 7. C. Correct. This filter is used for horizontal edge detection. As you can see, the center row is 0. So there will be a difference between the top and the bottom pixels. So it will detect the horizontal edge. Okay, like this. So option C is correct. So now we'll move on to the question number 8. So we have already seen the 1D convolution before. Now we will see 2D convolution. In 2D convolution, what we do, this is our kernel, that is 2 cross 2. Input is 3 cross 4. Kernel is 2 cross 2. So what will be the output size? Output size will be 3 cross 4 is there. What will be our output size? That will be 3 cross 2 cross 3. Because first we will keep here, see, correct. Because here we will keep our filter first, and then just we will, so in our filter here is w, x, y and z. So when we multiply, we'll get aw plus bx plus ey plus fz. Now we will move the filter rightward. So again we will get, if you multiply, then we'll get dw, because this w will just move on to b and x will move on to the c. Cx plus fy plus gz. Okay. And after that we will get cw plus dx plus gy plus hz. Okay. Because in the next time our filter will be here. And after that, third time filter will be here. Similarly, after that we will just move the filter one row down and we will start from here. Okay. So this is very complicated. So now that will be EW plus FX. In this way we just calculate. Okay. This is 2D convolution. So here we can also find the size, that is 3 minus 2 plus 1, that is equal to 2 comma 4 minus 2 plus 1, that is 3. So this will be 2 cross 3, means the output feature map will be 2 cross 3. So again we have to find the output for the convolution of the given kernel on the matrix. So how we will find? We will first see what is the size of this. This is equal to 3 cross 4. This is 2 cross 2. So our size will be 2 comma 3. So we'll draw the output feature map of 2 cross 3. So now we'll keep here, this will be 1 plus 3 4, and this will be 0 0. So this will be 4. So next will be 9, because just we have to just sum these two, because the down element is multiplying with 0. So we'll ignore that. So after that we will do 6 plus 7, that is 30. Now again moving to the down, that will be 2 plus 4 6, 4 plus 7 11, and 8 plus 7 15. Understood how we form this output feature map? Just because in the below row this is 0 0. What you texted? 535 what? Okay, maybe you have calculated wrongly. So like first we will keep this filter here. So what are the value? That is 1 1 0 0. So 1 into 1 is 1 plus 3 into 1, that is equal to 4 here. Again we will move the filter one rightwards. We will see 3 into 1 is 3, 6 into 1 is 6, 6 plus 3 9. Similarly 6 into 1 6, 7 into 1 7, that is 30. Now move the filter down. Again it will be 1 1 0 0. So that will be 2 into 1 is 1, 4 into 1 is 1, 4. So 4 plus 2 is 6. Again 7 plus 4 is 11, and 8 plus 7 is 50. This is the correct answer. We'll move on to the next question. This is the max pool. In this, what we do, let's suppose we have to do the max pooling using 2 cross 2 filter. We'll keep a 2 cross 2 filter, and whatever is the maximum value in that, we will just assign that value in the output feature map. So here the maximum value is 8, so we will assign like that. Now here stride length is 2, so we will just jump one way, and stride length is 2, so we have to jump two way. two times. So first time when we will jump, we will start from here. Second time we will jump, then we will start from here. So what is the maximum value here? That is 4. So we'll keep 4 here. Now again we will come down because the stride length is 2. So we'll jump here 1 and this is 2. So now what is the maximum from this? That is 7, and again stride length is 2. So the maximum from here is 5. So this is the way of maximum pooling. If it is told to do average pooling, then what we'll do, we'll do average of it. That is 4 plus 1 plus 5 plus 8 divided by 4. That is 12 plus 6. 18 by 4, that is 4.5. Like that. Then the stride length is 1. Then first we will do here. Second we will go here. And third we will go here. So what is maximum here? 8. In second also it is 8. In third it is 4. In that way, stride length is 1. So we will move 1 down like this. Okay. And we'll find the maximum among this 2 cross 2. Okay. So in this way, we will get the max pooling. So now we'll solve one question based on this. Perform max pool operation using a 2 cross 2 filter with stride 2 for the following matrix. So we have a 2 cross 2 filter. So from here, what will be the maximum? Maximum is 4. Now the stride length is 2. So we will move 2 steps rightward. So when we move 2 steps rightward, we'll come here because stride length is 2. So what is maximum from this? That is 8. Stride length is 2. So we'll move this to here and again this to here. So this is our next where we will keep the filter. So in this maximum is 7. Again, use a blue color. Stride length is 2. That's why we are moving 2 steps rightward and downwards. So here it will be 11. So this is the max pool of this question. We'll also solve one question based on the average pooling. Given the following matrix, what is the result of average pooling operation? And here also this is means the filter is 2 cross 2 and stride is 2. In this also filter is 2 cross 2 and stride is 2. Those who have joined late or who will attend the session later on, they can see these lectures on YouTube that will be uploaded. So in this we have to do average pooling. So what we will do, first we'll keep our 2 cross 2 filter here and we'll find the average of this. So average will be 10 divided by 4, that is 2.5. Okay. The stride length is 2, so we'll go one step rightwards, again second step rightwards, we'll do here. Average will be 7 and 11. 18 divided by 4, that is 4.5. 7 plus 12, 14, 19. 19 divided by 4, that is 4.75. Here 16 plus 16, 32 divided by 4, that is 8. So this is our average pooling result for this input using the filter of 2 cross 2 with a stride length of 2. So today our lecture is over. We have solved 10 questions based on the basics of this week lecture. And those who have joined late, you can watch this lecture on this tutorial session on the YouTube. The link will be provided in the course portal on the NPTEL website. So thank you everyone. Today we'll end up here.